All right, so now it is my pleasure to introduce Ivan and Waleed from Zalando to you. They will share insights how to design and build, well, a search platform, an architecture for search. And I think nowadays with search consisting of multiple components like retrieval, ranking, all the faceting stuff, sorting, re-ranking, it becomes more complex, so bringing everything together in one architecture, I think, is highly relevant to all of us. So please take it away.
Thank you. I'm Ivan and Waleed from Search and Browse platform. We are going to talk about architecture and certain components of our system and how they bounded with each other and work together, because actually this pretty simple scheme is several teams, several departments even, and we have like a lot of different applications and they work all together, providing for more than 50 millions of customers in Europe good experience in fashion shopping. So we have two parts. Waleed is gonna talk about base search and NER and how it works all together, and orchestrated search. And also another thing, we did migration of ranking logic, and I will be covering it later on. System is pretty complex, but eventually when user hit main page, we have this pretty good working heuristics. You are choosing gender, and most of your journeys, if you choose to go with high level filters, and basically when user goes through it, it narrows down to what you want to find. With different ways. You might type query, you might use filters or catalog, or you might use now also Zalando Assistant, which is conversational interface. Yeah, Waleed?
Thank you, Ivan. So why search architecture is a product topic? Currently, like Ivan just said, we serve more than 60 million users every year, and there are multiple things and multiple applications that comes into a single search architecture. This makes a single search system a product as a whole, which has several moving components, and we'll go through most of them today. And one thing that we wanted to note here, both these search entry points, both the search bar, both the Zalando Assistant, the chatbot that we have, they use the same support system that we have in the backend to serve our users these products and give them the relevant products that they're currently looking for. This is the end-to-end system at a bird's eye view. First, we have the intent qualification. Thank you for the next mic. Hey. Then we do the NER builder, which basically is the name entity recognition system. It takes in input, gives us some entities to work upon. Then we have the base search based on Elasticsearch, and then we have a gateway that fans out our different kind of requests that's coming in to different components based on A/B tests, based on other dependencies, based on certain rules that we have. And then the main search API, which is our wrapper on top of Elasticsearch and other systems that basically makes requests to our data source. At the end, after we get results, we want to re-rank them again to make sure the relevant products are at the top of the results. Like I said, the first step in a search system is to understand what a query is. It's understanding what the user intent is. And for that, we have an NER system that basically interprets the raw queries, filters, generates entities and systems that we can work on. And the thing that we want to work on is never show the users zero results. Don't show setbacks, that we call it. Don't show empty result pages. Always show something that the user is looking for, even if their query is a little bit messed up. This is our overview of our query system, the query understanding pipeline. The first step is standardization, which essentially is to tokenize a request. That's the first step in search system. Clean it up. If there are bad words, just remove them. Correct the spellings. After that, we come to the NER system. We have two NER systems in Zalando. One is a simple dictionary-based NER system. It takes in our article snapshots, generates a kind of a dictionary that we can reference on when we get a query. And the other one is an LLM-based neural NER, we call it, which basically has predefined or pre-generated queries or responses that we use for some certain set of queries, for example, low-performing queries that we have. After that comes intent classification, which basically means if a user searches for Nike and nothing else, they want to see only Nike products, just redirect them to a Nike product page that we have. If they're in a male category, for example, and they search for kids' shoes, they are not looking for adult shoes, they know those sizes, redirect them to the gender page of children and show them the kids' shoes, for example. And then comes the enrichment. This is enriching our understanding of different queries with similar words, some configurations that we have, some items to make sure that all of the relevant context is added to our entities to provide our systems, the underlying systems, with enough data to just retrieve those data. And at the end, we have fallbacks, which is just adding flags to our query understanding that we don't really get anything from this, just use our models that we have to just give them some results. This basically means that we couldn't get any kind of entities outside of, like in our systems, we couldn't recognize any entities. We just set them unmapped and then give them back to our gateway that we have. And this means they will just enrich the data set based on the results from our models. And then comes the search and browse gateway that we have. This basically is after we get a query understood, we want this gateway to work on what is the data that we're getting. The search API, do we want to call the search API with this entities that we have? Or do we want just to call the search API with the models that we have, the query embeddings that we have, and just get the data from there, enrich the data, and just give them back to the customers? Or it also works as a last endpoint for our redirects. So do we want to redirect to a brand or not? Do we want to redirect to a gender or not? Do we, does the redirect that query understanding just make, does it make sense or not? This is where we just verify that. After this comes our search API, or origami as we call it, which is the gateway between our Elasticsearch data source, our ranking systems, and this search gateway that we have. And how does that work? So these are like the 5 steps. It's a huge system. I have tried to compress and compress. And these are like the 5 main components that I found. First is we still want to validate the query and the entities that we are getting here. We want to parse the body and just make sure that we don't mess up somewhere. And then after that, we apply the staging rules that we have, which is basically some certain categories and certain types of sorting that we have. For example, if somebody's sorting by popularity, if somebody's sorting by new in, the new products and stuff like that, we have certain rules that we want to apply here. We also want to inject negative filters and perform the semantic search after that. this is the step where we get the query embeddings, which I think Ivan will go over. And the product embeddings. The product embeddings are inside of Elasticsearch. Query embeddings are that we get for each user. These are personalized query embeddings that we have. And then we call the promotion orchestration that we have. This layer basically makes 3 to 5, depending on the query, to our different systems to get promotion candidates, some sponsors candidates, and different kind of like new data and some promotion candidates, and we then try to merge them. This is the promotion and fetching. This is basically where we try to get like different kind of categories of data, and then we want to re-rank them after that to make sure that every result has enough data of different kinds to make sure that it can answer a customer's query. At the end, after we merge them, we just do a simple SKU lookup to make sure there's no deduplication as well. And at the end, we just publish the event data to Nagari for tracking and analytics. So I've mentioned a lot of query embeddings, re-ranking right now, and I think Ivan will go over the whole ranking process.
Yes, thank you. Ranking in certain ways stays in base search, starts in base search, because in base search are part of descriptions. We also have embeddings, and for users who give consent for personalization, we're able to personalize search. And basically this happens on candidate selection level, and after might be some application of ML models. Due to complexity of system and many applications and code, there is certain centralized configurations. We call it like search steering, even also touches browse flow, which is when you browse through catalog. So ML model could be applied on some top of results, because you don't want to put like 10,000 of results in some huge model. You want to do some base retrieval, and after you want to maybe iterate one or more times. It depends. It could be different also. You might want to apply certain features on top of an existing model. You want to experiment with this. You might want to try something like wishlist studying or something else to improve results, improve engagement or KPIs. And we used to have ranking logic encapsulated in one big application. So this ranking logic for ML models, we call it like re-ranking with some heuristics were extracted in separate application. It happened like this here, and so. We did architecture refactoring for this. So in order to be able to apply different models, different heuristics, and try to do some parallel sequential, like basically we moved to a certain way of computational graph, which is could be set by configuration with dependency of steps. When you have one model, maybe for 1K candidates, and when you have another more heavy model, maybe for top 100. So for this, we did this refactoring where you first, in parallel way, you enrich results with scores, values, features, and after you apply in order to get this final result. This was pretty significant change in model execution pipeline. Yes, and we were doing it in very strong technical requirements like 99 percentile. If you have many stages, many calls, many services, each service become more crucial with 99 percentile, and because one service could contribute and break whole latency, and when this application does not have time in budget and this is not applied. Yes, so we use Hopswork for feature storage, and when we were migrating, it was pretty tricky to validate it because some of heuristics were non-deterministic, and you don't have to compare all cases. So in order to enable more A/B tests and make it more easy, changeable, and whole system more flexible, we did this refactoring, and now we are trying to do more A/B test with this. Yeah. Thank you. Questions?
Who has a question?
Hi, thank you. Thank you for a great talk. You seem to have quite a lot packed in there. How do you approach defining your latency SLAs when you work with so much? Do you keep pushing the boundaries, or what's the main approach?
I think it starts from front end, and it's very much like pretty big, but SLO of other systems, it's just very strict. You have network latency, and you have 99 percentile, and you have processing latency. It's usually 50-50. So, and you budget it. More upstream you go, you increase this budget. Maybe ask more specific question.
What I wonder is, as you were adding more features into your search, did you have to push the latency,
parallelize? I think no.
So you stayed within the original boundaries.
It's pretty strict. So whatever not fitting, just fall back.
Hi, thank you for the talk. For the user perspective, your system is offering functionality for which parts of the website and mobile? It's like homepage, the search experience, I think is pretty clear. Also in the home, in the product page. So where is the system is being using in the user perspective?
I think it's everywhere.
Everywhere?
Yeah, it's there are many systems like mobile web, but they all go to same. So we have different paging sizes, offsets, but eventually maybe sometimes different features, models. It might vary, but in general it's all same.
Thanks.
Oh, sorry.
Yes, you said you rank multiple query intents. Do you only use the top, or do you use several intents and blend?
There is phase of intent interpretation. Maybe Waleed, you.
So in the NER step, we do generate 5 intents for each query, and we do choose the top one. We have a scoring system for each intent, and then we choose the best scoring one. Yeah, does that answer your question? Yes. Yeah, perfect.
Thanks. You said you always want to show results. Have you got A/B test results for this conclusion? Or so you always want to show results for random letters, random numbers? Always show a long result list? Or
Of course, it's the garbage. If you like 1, 2, 3, 4, 5, or like you just pick garbage there, we will probably not have that something there. But if it is like a real word or a real something, we'll try to like. It's like 99% of the time we'll be showing results. Yes.
okay, and have you got A/B test results that it's better than showing a 0 result page?
For us, it is, and I think it's been that way for like a couple of years now. So we did an A/B test, I think 2022, 2023, I think, yeah.
Okay, thanks.
Excellent presentation. Thanks a lot. Super informative. I'm curious, since you have such a sophisticated system already in place, anything that you're looking forward to experimenting with in the short term, maybe to show in next year's MICES?
There are a lot of things in work right now, especially since the age of search is like booming right now. We have a lot of new models coming in, a lot of new technologies coming in, and we are at the moment experimenting a lot at the moment. So like currently today as well, I was looking at some other experimentation documents that we have. I'm not sure if we can share those experiments right now, but there are kind of things. No, like there's a strict corporate requirement that we have.
Building up the hype, that's cool.
Yeah.
Thank you.
We all need to come next year again to hear the next talk.
Hi, thank you very much. I also don't know if it's super NDA-ish, whatever I'm asking, but I hope you will share. How do you retrain all of these parts of the systems? I see so many movable parts and there is so much drift possible with the data changing over time that you kind of need to be very precise at the keeping models not stale. So how do you approach all of this Frankenstein?
It's a difficult question. But there are some metrics, yes. So basically you check metrics and you see like historical also stats. And basically whatever goes wrong, yes, it is analysis because all like each search attributed and each search is like with some result with funnel. Yes, so basically you can see and you have see the zonality and you can check it. Yeah.
And we also have a pipeline as well. So most of our models are getting retrained every certain time. Yeah. So for example, one of our models we'll retrain every day. There's other that we train like depending on like certain data points that we have. Like Ivan said, there are certain metrics that define if we want to retrain the model or not. But there are pipelines in place that will retrain every certain time. Or, yeah, that's.
No, that's super cool system. But can you tell? Did you ever have a story when something went really off in this big system atomically and you guessed it the wrong direction for retraining? So just to know what can go wrong, because it's always the funniest stories when something goes wrong.
Ivan, if you.
Yeah, we try to follow certain things what we share, like because it's like very. It's pretty strict. It's corporate. It took me a pretty long time to get through process, so this talk is fine.
So we turn off the recording for now?
Yeah, but in general, I think also like it's pretty practice. You retrain model and you have certain KPIs. Like it's not related to Zalando. It's like I think it's general. Whatever you have order drop. You immediately react and you narrow down. And when certain problems might happen, sometimes your UI change might cause it. So sometimes you just change amount like your layout, how many your first line. And like and when your whole train data, because if you have like 2 or 3 or 5, and when 6 7th, and next one is going to be very much different in click rate. Yeah, so and this click rate usually influence very strictly, so it has tendency to pop up. Yes, and model is aggregation of statistical things. So basically, whatever you have it, you introduce this bias with model, and it can influence your click. So you can have back click. I think it's like it's research, and it's like everywhere. Like everybody faces same, less or more consciously, and you need to look into your data. And usually, analyst, okay. This happen, you go to analyst, and analyst is able to conclude, okay, on which view event it happened, and when it's become more obvious, like what's wrong. Yeah.
Thank you for the presentation. Can you go for one slide before about the implementation constraints?
Yeah.
Yeah, I'm just curious. So basically, you have as a constraint the ML model inference. Does it mean that you have your own infrastructure for the machine learning, or did I understand it correctly? And why is it
it's
constraint?
latency. It's latency because when you call model, you have latency, and this is pretty strict because this influences your whole budget of latency.
Oh, okay.
More questions? Then let's thank our speakers again. Thank you very much.
Thank you.